Hello, everybody. Thank you for taking time to join us on this training series. My name is John Gomez. I'm the CEO and founder of Sensato. I'm just going to tell you a little bit about us, and then we're going to jump into the content for those of you that are not familiar with us. Sensato is a critical infrastructure cybersecurity firm. We do a lot of work specifically in the healthcare sector of the critical infrastructure sectors. Variety of different things we do, from advisory services, which include things like risk assessments, security architecture reviews, virtual CISO program. We have our own security platform known as Sensato Nightingale that we've designed and developed from the ground up. We provide a variety of different managed security programs, as well as do a variety of different types of training and testing, including application security, incident response training programs, penetration testing, and writing secure code programs. We have an amazing amount of great partners. I won't go through all of them. Truly appreciate all the partners that we do have and how they help contribute to what we do each and every day. As a company, we tried really hard to focus on helping organizations comply with best practices and regulations, as well as help to detect attacks and identify anomalies and security issues within their environments, and ultimately respond to those in a hopefully tactically efficient manner. The other premise to our foundation and our thesis, if you will, is that we ultimately want organizations to reduce liability. If something does happen and there is an attack of some nature, really work hard to try and put in place the best practices, the regulations, the detection capabilities, and the response programs that help them ultimately reduce their liability. And we do this by hopefully helping them to more efficiently and effectively defend themselves in court, if that's what it came down to. So that's the second part of our thesis. That's kind of the foundation of our company, if you will. One thing, especially because of the training that we're doing here today, to keep in mind is that we typically, aren't the typical cybersecurity firm, and you may hear that from a lot of people. But I can tell you, when I started and founded the company, I didn't want to continue subscribing to this notion that everything is great and that we have all figured it out in cybersecurity. What I found is that the emperor has no clothes, and a lot of the stuff that we subscribe to, think about, especially blue teams and defenders, is far from the reality of what attackers can and do. And so we're going to talk a little bit more about the genesis of this training program and why we decided to put this together in a moment. But the one thing I want to kind of highlight is there's some things you may hear that are not part of the status quo or the common understanding of best practices. And so hopefully, ultimately, you keep an open mind, take away from these what makes sense to you. Obviously, we're always learning. We don't know it all. Love to hear from people all the time, but our hope here is to kind of get people to think a little differently about cybersecurity ultimately. So this is a 6-part series, and each series kind of builds on the last class, the last training evolution. And I kind of try to do this in a way that might be a little more fun than most training programs. I guess time will tell if we hit that objective or not. But we're going to go through a bunch of different things, and I'll explain why we pick these topics over the next couple of slides. But what we're really looking to do is kind of always take a view of the attacker's perspective. Always through this program, we're going to assume that we are all working for a nation state. So the tools and the techniques we have at our disposal are pretty powerful. But we're going to talk about that as well in terms of the severity of the types of attacks that we use and the techniques that we employ. So this program really kind of were 3 things that we were trying to do when we designed this 6-series program specifically. One was, we have a security operations center known as the CTOC, the Cybersecurity Tactical Operations Center. It's a 24/7 SOC. Many of you are clients of it. Some of you are maybe just learning about it. But one of the things that, as I go through cases and I review cases with the director of the CTOC, and we kind of review phone calls and how cases are managed. And one of the things that became apparent to me is that a lot of what we see happening, which leads directly to a false sense of security, is the defender's viewpoint. And I've run into this several times, a lot of times actually, in speaking to defenders, whether that defender is a CISO or it's somebody on the ground, or maybe it's somebody who's an IT person and doesn't have a security background. But you know, I've really kind of, the defender's viewpoint is always interesting to me because I'm an attacker. And the defense work I do is because of my attack capabilities. And so I've done attack work for a very long time. And I kind of find it interesting when people say things when they're rationalizing an alert or they're rationalizing an incident. And so we hear a lot of times, like, I don't see this, like, I don't see this in the firewall log, so it can't, you know, must be a false positive, or it's not possible. Or, you know, I have geocoding in place, so how could it be that I have an IP address from Russia pinging an internal device? And so it's kind of interesting to me, and that was a big piece of why we put this together, because I really feel that as defenders, maybe we spend too much time just thinking about how do we lock things down and close down gaps, and we don't understand how attackers actually operate. And I'm not talking about certified ethical hackers or people that do pen testing, with some very, very rare exceptions. For the most part, I think that unless you're really truly an attacker, your mindset is very different. And you work within a set of rules and a set of boundaries. And so we're going to try to push some of that on throughout these 6 series. And so that's really the attacker's perspective, right? It's rarely employed or understood from a defender. Like, I think the most effective defenders are those that can really think like an attacker. And so I think it's a very different viewpoint to think as an attacker. And hopefully, as you go through this program, you'll walk away with some of that that mentality. Maybe you already have it. I obviously don't know everybody attending. We've had an amazing response to this program, so some of you may be on the attack side of this. In fact, I know 1 or 2 of you attending are. And then the other thing is, you know, the attacker's audacity. What we're hoping to demonstrate throughout these 6 series is just truly what is the audacity of the attacker. And again, all this comes back to helping, hopefully, defenders understand that sometimes the things you don't believe could be done, or the things that you aren't aware can be done, or the things that you're rationalizing are the first hope of the attacker. They're ultimately that first chink in the armor. Because as an attacker, I'm betting heavily on you not responding to little things that I do that ultimately give me a great and a huge return on my efforts. So there's a few things in this program you know, that you may hopefully want to take away. One is just-in-time auditing, meaning as we're going through these different scenarios and these sessions, a great thing to do is go, you know, could that happen here? And why wouldn't that be able to be done here? Or has this already happened here and I kind of rationalized it? Maybe I should go reopen a case or take a second or third or fourth look at something. Because maybe through going through these programs, you may have better context as to how people can do certain things. You know, obviously we want to help evolve blue team skills here. We want to make sure that, you know, your skill set in terms of identifying what to defend against and how is broadened. Ultimately, that means that you're taking offensive computing, which is what an attacker obviously does, and applying that as a defensive and strategic tool. And then if you keep doing that, right, the more you do that, the harder it becomes for attackers, right? You got to really they got to force their creativity. Unfortunately, we do live in a world right now in the cybersecurity profession where most of the things we do, and I've said this so many times when I've presented to different audiences. I remember saying this back at presentations I've done for DEF CON several years ago, that most of our practices, most of the things we do on the defense side are really kind of from 2010. They haven't really evolved that much, you know, and you know, as I said, there's some other attackers that are on this call with me, and I'm pretty sure they're probably would agree that, you know, the attackers' capabilities keeps evolving, but we don't see much difference in how defenders defend environments over the past 10 to 12 years. So maybe we can kind of come together and help evolve that and put attackers into a position where they really start having to be forced to drive to a higher level of creativity if they want to breach the systems that we're responsible for. And nothing, I think, says this more than a study that came out in this past October in 2021 from the New Zealand Cybersecurity Center. And this was kind of eye-opening to me. And again, this is part of the germination behind why I wanted to put this program together. is that there was a study done by the New Zealand Cybersecurity Center which looked at ransomware attacks since 2016. And they looked at all attacks across the entire world, across all different sectors. And what they found in that attack, which I think is just absolutely stunning, is that 87% of ransomware attacks, successful ransomware attacks since 2016 across the world, across all sectors, employed low-tech approaches. So I want to spend a minute or two on this because I think this is really eye-opening, and it goes back to what I said, that we're just using 2010 techniques to defend systems. And what this really translates to is that, you know, the techniques that are being used by attackers aren't these really sophisticated Mr. Robot kind of approaches, right? They're real simple stuff that's been around since 2000, well, actually way before this. Some of the attacks go back to the late 90s, early 2000s, and they haven't changed much. You know, when we deconstruct a ransomware attack, you know, a lot of the ransomware attacks, I don't know how many of you know this or not, and I did a session on this long ago, where we deconstructed the code behind ransomware. And the code that most ransomware attacks were using, or still are using, was actual sample code for C#.NET encryption, right? So it was basically code that Microsoft put out in their MSDN libraries. If you're familiar with that, it's basically a website where developers go. It's the Microsoft Developer Network, MSDN. And there's sample code that's used to show a developer, a software engineer, how to encrypt files. And it's not really sophisticated. It's like 30 lines of code. And then there's sample code of how do you move across the network and use SMB file shares to move across the network and evaluate file shares. And none of that stuff is really sophisticated. And so when we look at ransomware attacks, you know, they're not really like crazy sophisticated. Now, are there crazy sophisticated things out there? Yes, there are certainly polymorphic attacks. We've seen genetic algorithms. We've seen AI-based, ML-based attacks. But is that what 87% of all ransomware attacks is employing? Apparently not. And so that's kind of interesting to me because there's investments in all kinds of advanced antivirus and other things, and yet, you know, attackers are just kind of looking at code that's been around since, you know, whenever C# came out, right? It's quite some time ago, and they're just using that code base to kind of do what they want to do. So I think we have to all kind of step up our game, and hopefully this series, I don't think is going to solve any of that, but maybe it'll give you a different perspective. And if even just one of you can walk away going, you know what, I'm going to look at things a little differently. I'm going to take a second look at this alert. I'm going to take a second or third look at what I'm being told. I'm not going to rationalize it. I'm going to really try to look at this from an attacker's perspective. Maybe that'll make at least one organization a little bit safer. So that's my hope, hopefully to at least help one person out of all of you that are attending get a little bit better. And just another thing is, you know, hey, if you got ideas on things we should cover, something I say that's wrong, an idea of an attack that we didn't deconstruct or look at throughout this series, please reach out. If you want to present, if you want to put together a class, we'd be happy to use us as a platform. We really want to make a difference in the community. So hopefully this is the start of that, and we can continue building, and some of you can help share what you're seeing and how you address some of this stuff. So in this scenario, and what we're going to be doing is we're going to be pretending throughout the six series, the 6 sessions that we're going to do, we're going to pretend that there's this country, a small country known as the People's Republic of Pineland, and it's on the continent of Atlantica. Now on that continent, there's some other countries that you can see here on the map. But the nation of Pineland has been a real powerful supporter of the United States through World War I, World War II, Korea. So they've been a really strong ally. They're a small country. To the north of Pineland, as you can see on the map here, is this other country called the United Provinces of Atlantica, and which we're going to refer to as UPA going forward, just too much to say. But UPA, this country borders the northern parts of the nation of Pineland. They have recently acquired some medium-range missiles, and there's been movement in that country to try and pressure Pineland into becoming an ally, or at least becoming part of annexing that country. Now, before anybody says anything, though, this has nothing to do with any current events. This map that you see has actually been around for quite some time. All of this comes from the final graduation exercises of the U.S. Army Green Berets and a program they go through called Robin Sage. So I basically took their Robin Sage artifacts and used that as the basis for our scenarios and what we're trying to do here. So ultimately, this nation of Pineland has requested international assistance in helping evaluate the capabilities of this other country, given that this could potentially be a threat to their sovereignty. So with that, just to give you a little bit more and kind of bring you further into this, is the role that we're going to play here is that all of you are part of a National Crisis Management Center known as Op Center. You are part of that team, and throughout these training sessions, I'm going to ask you to think about this from the attack side, and that you are part of this kind of organization that's a team composed of intelligence analysts, cyber warfare specialists, and ground operators. And those ground operators will become important towards the fifth and sixth session that we do in this training program. So right now, we're the ones on call, and we get the request to attempt to infiltrate critical infrastructure systems within the United Provinces of Atlantica, or UPA, as we mentioned. And really what we're trying to do here is determine, how resilient are these systems to cyber attack, and possibly what can we learn about these systems to develop future intelligence gathering efforts. So our mission tasking in all this is that we're authorized to identify vulnerabilities related to critical infrastructure networks. We should not exploit any vulnerabilities at this point in time, and we should focus on external facing infrastructure that has a high return on investment. So we're really kind of just looking at the perimeter and seeing if there's anything we can do to get beyond that perimeter if we need to be. But at this point, our task orders are not to breach, but to really just understand the construct of that perimeter environment. Now, just to take a pause in this storyline. So a lot of this that I'm going to be sharing with you in terms of this tasking and how this works and what we do does come from some historical context of things that either I or some of the other people on the call have been involved in. So I'm trying to at least put you into the mindset as real as possible of how a mission like this unfolds and what the attackers are thinking about. So one thing that you should probably do, I'll give you a minute or so to do this, is think about if you were actually part of this team, what would be your next steps? Like, what would you do? What methodology would you follow? What would you try to employ to take your next steps in going after your mission tasking? What would be your next immediate critical task that you would want to do, right? You've been tasked with this mission to go and explore critical infrastructure systems within this other country. And we've already covered what you're allowed to do or not do. So I'm going to give you like, I don't know, 30 seconds or so to just think about it. I think this is an important point in transitioning from being a defender to really being an attacker, assuming you're not an attacker at this point. And if you are, that's great. You may already know the answers to this, but I'll give you a few seconds and let you think about that. Okay, so net, there's no real one answer to this. There's some things I can tell you that I believe are the status quo and things that people do on the pen test side or the ethical hacking side, which probably I guess kind of makes sense, but they don't really reflect how attackers actually carry out their missions. So I wanted to take a little time to give you a chance to think about that, because you're probably maybe thinking about it from a pen test perspective. But I want to kind of talk to you about how at least I would execute a mission and use this as a foundation. So typically when I train teams to do attack work, or I'm doing attack work myself, this is the methodology that I use. And for those, some of you are very familiar with the kill chain stuff. You might be surprised that it's not what I'm putting forth here. And the reason for that is attackers don't think that way. Like, we don't bring out the attack kill chain and go, okay, let's do this. Now this is somewhat similar, but there's some distinct differences, and I'm not going to go through this whole thing, but I want to kind of start getting you exposed to it, because there are some key differences here between how you may think of this as a defender versus an attacker. So the mission planning is what we're doing right now, and if you're dealing or defending against cyber criminals or nation states or cyber terrorists, chances are you are going to see that they have a mission plan. And I can tell you that we can draw upon experience some things that are kind of public. For example, there was an attack out of Germany that many of you may be familiar with, where a hospital was hit by ransomware. Unfortunately, a person was diverted from that hospital to another hospital and died en route to that second hospital. Now, during the negotiations between the hospital and the attackers regarding the ransomware payment, when the attackers learned of the name of the hospital that was contacting them, the hackers apologized and said, oh man, we're really sorry. We actually weren't intending to come after you. We were intending to go after this much larger university hospital. So we really are sorry. Here are the keys. You can decrypt your files. And, sorry. Now, the reason I bring that up, as unfortunate as that situation is because it does show you there was mission planning done here. The attackers really thought about who they were going after. Now, there was some kind of communication breakdown, or maybe there was an error, or somebody typed too fast, or whatever they did, they hit the wrong hospital. Now, does this mean that every attack has mission planning? No. But as a defender, you should be trying to think about the most sophisticated attackers. If you're defending against some dude or dudette in a basement in Brooklyn, that lives with their mom and doesn't see the light of day very often, then that's why most of the stuff we do is so dated. If you're thinking about how am I defending against people that are doing actual mission planning, then you're going to have to step up your game, and that forces you to do that, and that's what we want the outcome of this training to be. So once mission planning's done, right, once we have our mission tasking, which is what I gave you in the last couple of slides, you're then going to move into intelligence gathering. And this is, a pretty in-depth thing that gets done, right? And I'll explain a little bit about it. We'll talk lightly about what we do. And if some of you want me to go deeper into intelligence gathering, I'm happy to do that. We're going to touch on a couple of things, but nothing really deep. But enough to carry out our mission, right? And that's probably the worst part about this is we're going to do enough to carry out our mission. And it's not a lot, right? Which is sad. Then we get into vulnerability assessment, infiltration, exploitation, and exfiltration. And we'll go through these again kind of as we go through the series. But the one thing I want to draw your attention to is vulnerability assessment. Now, vulnerability assessment by the attacker, this is your best chance of detection. This is your highest possible chance at detecting someone. This is when they're going to be the noisiest. This is when they're going to show their hand. If you do not detect an attacker at this point, when they're trying to assess your vulnerabilities and move to that next stage, chances are that you will not catch them. And if you look at things like the Verizon report and AT&T and others that, kind of year after year after year say that, the amount of time an attacker with an ATP style network, ATP type attack stays in a network is anywhere from 160 to 220 days on average before they're detected, it kind of helps illustrate this. And again, this should be pushing you to think about like, how good are we at detecting an attack? This is the noises. We don't get them now, right? Then we're not probably going to find them unless you do some other really, crazy things that most people don't have the funding to do. And then these other things here, what I'll tell you is, if they get in and breach your perimeter and they're in the network, then these steps keep repeating themselves until they're done with their mission and they exfiltrate. And that's why we see this attack modeling here, right? So as the attack continues, as the attackers, we return back to our conference room and we start thinking about, now that we know that they have this, this, and this, what do we do next? And we'll address some of that later on. And just like in most situations, whether you go through incident response or a network outage, you have a lessons learned. As attackers, we're going to do a mission review. And we'll talk about what worked well and what didn't, and where we can evolve and what we just need to keep doing the same of. So just want to kind of change your mindset to at least how I think about it and how I train others in this space to go after these kind of things. Again, you can use whatever you want. There's no real right or wrong answer, but I think that, hopefully looking at it a little different gives you a different perspective that you can try on. So right now we're going to look at just mission planning, intelligence gathering. So from a planning perspective, what we would do if we're all kind of sitting in the same place or virtually working together, we're gonna focus on the XFIP. We've been tasked to go figure out what vulnerabilities can get us inside this network. So we're going to evaluate technologies typically employed by the UPA country to protect internal networks, right? We all know what those things are: firewalls, VPNs, things of that nature. We're going to identify possible vulnerabilities that could be exploited, or we're going to fingerprint assets for craft tasking. I'll come back to that in a moment. And then we're going to identify secondary targets of interest. So this is going to be, if we say, okay, 3 of us are going to go after, start executing on this mission, those are going to be the things that we're going to look for, right? We're going to look for what can we identify amongst the perimeter that we can breach. We're going to identify vulnerabilities. We're going to look at craft tasking, and we're going to go look at secondary targets of interest that in case we need to do something else later, we have that secondary list of targets that we may be able to go after. So craft tasking, all that simply is when we create a specific handcrafted attack for something, right? So we may come up against a system, a firewall, an application, an operating system, whatever it is, where we can't find any vulnerabilities, or we can profile the communication in such a way that we can start exploring intermediate level attacks, right? Which would be handcrafted. These are when we really build something specific to that environment. And so we're always on the lookout for those because those are really hard to capture. They're kind of like 0 days. They may be 0 days, but this is, a real big bounty for us as a team is to figure out, are there opportunities for handcrafted attacks, right? So that's kind of our plan, right? So we've built out our plan, and we're now going to move into intelligence gathering. Now, sorry. The big thing here that we need to focus on is being covert. We have a priority to be covert. We're working for a nation state. We don't want this other country or any of the entities in that country to start getting suspicious that we're coming after them. And so we need to be covert. So I'm going to give you a second or two just to think about how can we be covert? What would you do if you were on this team and you had to raise your hand and we were like, hey, how do we stay covert? What would be your suggestion as part of this task unit? All right, so all of you came up hopefully with some ideas and thoughts. So, but ultimately we want to do is something like this, right? Wherever we are in the world, we want to feel as if the target or the victims can't figure out exactly where we are, right? We want to be able to bounce around and figure out like a way to ultimately make ourselves anonymous, right? And hopefully still be able to do this in a way that even though we're being anonymous, we can still maintain and manage communications and not reduce the quality of our attack or the efficiency of our attack, right? We want to be able to make sure we can carry out attacks without our anonymity getting in the way of us being able to establish command and control or do other things of that nature. So what we want to do, the term for this, for those of you that may not know, is proxy chains, right? So in this situation, you can see here, we start out in, well, it depends on which way you want to look at this, but we start out in the US, we go down to Australia, we jump up to an Eastern European, go back to Eastern Europe, we cut across the world into Asia, and we move up into Western Europe. And we do a bunch of hops, right? And each one of those has a distinct set of IPs, so that if somebody does try to get suspicious, they're going to have to dismantle what we do. Now, I'm going to go to the next slide. So basically, pretty straightforward, right? We have a series of proxies between us and our intended target. Now, the reason I want to bring this up and spend just a couple minutes on this when we're talking about firewalls is one of the behaviors we see people bring up a lot of times is, well, why is that IP malicious? Or that IP is no longer coming up on a malicious list. Or that's a local IP. That IP belongs to, somebody down the road from our organization. So I don't know why that's being alerted. Why are you getting an intelligence hit on that? So here's the thing that you need to keep in mind. the first and most rudimentary about it is if you get an intelligence hit on an IP address, there are very few people that I know of that sit around and just create IOCs on random IP addresses. I guess you could do that if you have not much to do in life, or maybe you're trying to create some kind of noise and you want people to go and not pay attention to IPs and then ultimately use those IPs for nefarious means. But the point of this is, if an intelligence hit comes up, even if the facility or the organization involved is down the street from your organization, you really need to treat that as a very serious situation. Because it doesn't mean that just because it's coming from a IP address down the street, that it's not actually part of a proxy chain that originated in Russia, right? If all of us are tasked to go after a country and their critical infrastructure, the best thing we can do for our targets is to really go after them with IP addresses they feel are going to be okay to use. And that's what you do as a defender when you're like, well, this IP address, I don't know, it doesn't show up on any intelligence list. Why should I worry? Well, you should worry because at some point in time, there was a concern about that IP address. And you really have to balance with, do you really need to give somebody access to that IP address versus should you block that IP or URL or whatever it may be because at some point there was a suspicious activity. Now, I'm going to give you a real quick story here to kind of illustrate this point on proxy chaining and how using local IP addresses could come to be a challenge. There was a defense contractor here in the U.S. who had a facility in the Midwest, and they were being targeted by Asian interest nation states. And this is a real situation that occurred. It was actually pretty effective in the way that this attack was carried out, and proxy chains were used. Now, the way that this happened was ultimately the target here was the defense contractor, but they actually had a very secure network, very strongly defended network. It was a lot of work to try and breach this network. So this nation state decided to go social. And what they did is they kind of went out and they figured out who are the local businesses around this defense contractor, because most of the people that worked at the defense contractor lived in the nearby neighborhoods. And what they did is they went after a wedding photographer. This husband and wife owned a wedding photography business. And one of the services they did is they allowed you to log into a computer that they used. They actually used FileMaker, and you could then, as a couple, or whoever, your husband, wife, or whatever it may be, could look at the pictures that they wanted to purchase and use as part of their photo album, their wedding album. Now, what this nation state figured out is, hey, this is the only wedding photographer in this whole area, and a lot of the people that work at the defense contractor were getting married, and they used this wedding photographer. So what did they do? Well, they also knew that a lot of people on their lunch breaks would log into this website from the defense contractor and look at photos and then download them to their laptop so they could show their wives later when they got home, or their husbands or whatever. And that was their entry point, right? So, in this situation, if you would have got an intelligence hit on that wedding photographer and the rationale was, well, they're just down the road, everybody uses them, what's the big deal? I don't see them showing up on any indications. Then you may have let your guard down. And the same thing, that's a very easy attack to kind of pull off, because a wedding photographer doesn't have the assets that a defense contractor does, or a hospital, or a water treatment facility, or a manufacturer. But that's a real simple way to get inside somebody's network and beyond their firewall, right? So just wanted to give you that, because when we're talking about firewall compromise, a lot of times I think we're talking about some of the other stuff we're going to talk here, and you don't even have to go do that. You can just go get a partner and take out their network. So we want to set up a proxy chain, but how hard is that? Well, it's pretty simple. There's actually an application that runs on Linux called Proxy Chains. You even have 3 different types of proxy chains: dynamic, strict, and random. And you basically create a list of IP addresses, and then from this point forward, whenever you do any communication, you run it through this application called Proxy Chains, and it will manage routing your traffic through as many proxy chains as you want. Now, the more of the proxies you have, the slower your communication will be, obviously, because you're bouncing all over the place. But what I take away from this is setting up things like proxy chains and the sophistication behind them. Not hard to do, right? We could actually get a proxy chain up and running probably in 30 minutes. If you've never done this before, maybe take most of you on this phone call maybe an hour or an hour and a half, and most of that would be going to figure out the proxies that you want to put in place. Hint, use Amazon Web Services or Azure or Google Cloud. They have services all over the world that you can try to use. So not that hard, right? So now we have a proxy chain as a team. We're pretty effective in being anonymous. We could probably bypass geocoding because guess what? We can eventually get within the boundaries of the country we want to be in. So we've solved a lot of problems by being covert. So next step here is one issue we have with proxy leaks, and something you guys all should know about is DNS leaks. So if we're going to put a proxy chain in place, one of the things I want to make sure you guys take away from this is if you're going to carry out an attack like this, is be very careful about how your DNS is being done. If you're carrying out this type of an attack, you got to make sure that the computer you're using in order to get through the proxy chain isn't resolving DNS for a known DNS server. So let's say you're here in the United States, you want to look like you're coming from Romania, but you're using Google as your DNS resolution and here in San Francisco. So there's going to be a mismatch of your IPs. You're basically giving up your anonymity. This is also a challenge with things like Tor and some other stuff, where you give up your anonymity because of the way you do name resolution. So when you set up this proxy chain, you got to make sure that you're picking the appropriate DNS. And once you do that, and then basically your anonymity increases to the point where it gets very hard to figure out where you're coming from and that you're not actually your original location. And if any of you are going to try this, you can see this by going to DNS leak test, and it'll tell you where you are. And you keep tweaking your DNS settings and your proxy chains until you get the result you want. That basically, when you go make a request of the web, DNS leaks would tell you if we're trying to pretend we're coming from Romania and we're actually in the US, then DNS leaks will show you that, hey, your IP address is Romania and not the US. So hopefully that makes sense, but this DNS leak is really important to resolve as part of us being covert. As a defender, I'm telling you this because you need to be aware of the fact that, as an attacker, it doesn't take much, and I realize that maintaining my covertness is really important. If I want to look like that address down the street, or one of your trading partners, or a business associate, or whoever that may be, that I want to pretend that I am, it's not that hard to do. Okay, so we're going to get a little update on our mission. Apparently, what we're hearing is that diplomatic and economic ties there's another country here on this map called the Republic of Columbus, and they have very strong ties with the United Provinces of Atlantica, UPO, and we've been finding that that's a challenge. We're also finding that there are defense contractors in the northeastern part of the country of this UPA, and that this Republic of Columbus has been communicating with them. So probably for us setting up our proxies, our proxy chain, we want it to appear that communication going to these defense contractors appears like it's coming from the Republic of Columbus, right? So we want to, again, get into that neighborhood, fold into that normal traffic. And for things like firewalls, this becomes an issue because these defense contractors here in the northeastern part of the country are going to probably not be able to geocode the Republic of Columbus. Or they're going to have very strict whitelisting, which honestly doesn't hurt us very much, right? We'll figure out the IPs of who are these downstream or these whatever these contractors that they're interacting with. So, so understanding who these contract people are may be beneficial to us, right? Who are the employees of this defense contractor may be something that's real important. Is there a way to compromise them if we need to take future military action? Not so much attacking the country, but how do we go after possibly the employees of these defense contractors? And so what we can do is look at infrastructure sectors. And based on what we know of our mission tasking so far, one of the things we can do is prioritize healthcare, right? So we're going to focus on healthcare because why? Defense contractors go get doctor's visits, right? Their families are going to doctors. So if we want to find out about who works at these defense contractors, there's no need for us to go after the defense contractor right now. We may probe their external environment, but really what we want to do is figure out if possibly the hospitals may have information that we can get, like home addresses, phone numbers, next of kin, medical situations that we may be able to help, medical bills that they can't afford to pay, things of that nature. So we learned that there's 2 hospitals within this country, within that northern sector where the defense contractors of this country are located. And the rest of our tasking is going to really be to go after these hospitals and figure out how we can breach their perimeters. So at this point, we're kind of here, right? We've got our intelligence gathering, we got our mission planning, we put our covert capabilities in place in terms of proxy chains, and we want to kind of now figure out how do we figure out what systems are being exposed to to the external perimeter. What can we actually breach? And there's a few ways to do this. It's all open source intelligence. None of this is really, any kind of spooky shadow work. And again, this goes back to that 87% that New Zealand found, that most thing attackers are doing are pretty straightforward, simple stuff. So on here, I've got LinkedIn and Indeed. And you may be, hopefully some of you know this, some of you may be wondering, well, why would LinkedIn and Indeed be a intelligence source for an attacker? And it's not because I want to go and become friends with the targets. It's actually a much simpler reason, because most companies post jobs on Indeed and LinkedIn. And when they do, those job descriptions are rather descriptive. We want people with 3 years of Cisco iOS experience, or we want 6 years of XYZ antivirus software, or we need somebody that has a background in Windows 2008 to help us migrate to 2000 XYZ. So all of that are clues that as an attack team, we can start using to figure out what's vulnerable, what's been deployed, what assets are there, can we do specialized handcrafted attacks, are there known vulnerabilities we can go after without ever touching anything. Now, a secondary source that you can look to is Shodan. And what I would tell you is, if you're a defender and you're not going out to Shodan like once a month at the minimum and typing in the name of your institution or your external facing IPs, you really need to. I just went in and typed hospital VPN, and luckily for what I found a bunch of hospitals that had their VPNs that you could log into directly from Shodan. So you need to kind of, as a defender, be proactive. This is what the attackers are doing, right? If we're an attack team, this is what we do. Go look on Shodan. Say, hey, is Pineland University Hospital on Shodan? Has Shodan fingerprinted them? It saves us a lot of time. We don't have to come after you. So just something to know, right? The other thing, and this one actually I had a little bit of fun when I was putting the class together. For those of you who don't know about ExploitDB, ExploitDB or Exploit Database is just a database with Google Dorks. And this thing gets updated, you can see on the screen, there's some from today, right, 3 or 4. And these are just searches that you can do on Google. So again, I don't have to come after you. I can do this way. And what I did is I did a search for any exploits related to firewalls, firewall logs. Was anybody exposing their firewall logs? And when I did it, I found one organization who, sure enough, had their firewall logs exposed to the internet. They didn't know it, right? Their firewall appliance was misconfigured, and there's their firewall log. And I was like, it can't be a real firewall log, but yes, it is a real firewall log. So I was like, oh, that's pretty cool. And then I was able to get to their firewall rules. So this was awesome for me as an attacker. And some of you might be laughing and be like, oh my gosh, what you better really hope is you're not the organization that I found this on. Firewall misconfiguration and rule misconfiguration is one of the easiest ways for an attacker to get through, right? Nothing really serious here, but I could go from ExploitDB to a rule set, a log rather easily, right? And all I used to do this actually was Google. There was no real skill set that had to be employed here. Again, 87% of everything we do is low tech, nothing crazy. So we figure out that there's several portals being used by these hospitals, and they're being protected by WAFs, and some of the hospitals employ, obviously, perimeter firewalls. So our next step in this journey is going to be to go after these WAFs and to go after these perimeter firewalls. We just really, at this point in our mission tasking, want to figure out, again, are there any vulnerabilities? Is there anything we can take advantage of? So I'm going to I'm gonna show you guys a few things on kind of how we do this, right? And I'm not going to go real into depth because we don't have the time. I just want you to walk away with understanding some of the techniques here and some of the things that can be done, right? So we're now moving into vulnerability assessment. And this is the best chance of everybody getting us, right? So we got to be careful. We're going to move from being completely covert using open source intelligence and some arm's distance asset fingerprinting to kind of now starting to interact with systems. Now we have our proxy chain in place. We can change that up. Actually, we can use a different proxy chain every minute. So again, I want you to understand the audacity of the attacker. If we were doing this for real, are we going to set up one proxy chain and come after you with that so that eventually you see it's the same IP addresses through this proxy coming for you? No, we're going to set up multiple proxy chains and we're going to use different ones as we go through this. I'm going to show you some other decoy stuff that we can do. So we're going to start by going after the WAF, right? The web application firewall. So we're going to pretend that there's a portal out there. We've discovered it. And we're now going to try to figure out, can we get past this web application firewall? Now, what I want you to understand is at this point, we are not trying to circumvent the user ID and password. We're not trying to figure out, can we somehow, get beyond the application itself, the portal applications. If you have like a login, like a patient login, a provider login, a end user employee login, we're not trying to get past that right now. We're just trying to figure out like, oh, okay, you got a web application firewall. Kudos to you because that's a good thing to do and you should all have that. If you don't have a web application firewall in front of every portal that you have public facing, you really need to make that a real big priority. But let's understand, even with that in place, is there something we can do to get past it, right? Because I want to kind of get us all past this rationalization that, oh, I got a firewall, I got a web application firewall. I don't see how that could possibly happen. So there's a tool out there called WaffWoof, right? Literally like a dog. And what it does is it helps us detect a firewall. And it makes my life so much easier because in the past I had to write all kinds of like crafted TTL stuff and a bunch of other stuff and port scanners to go out and figure out what kind of firewall am I dealing with. Thankfully, to open source and hackers all over the world, they built this tool called WaffWoof. When you run it, what it basically does is it comes back, and you can see here on the bottom, you could point it like at GitHub, and it'll tell you what web application firewall they're running. Why is that important for us? Because it saves us time. And secondly, we can now go look for, are there vulnerabilities related to Sophos, or has somebody else done something for Sophos, and can we find a way to handcraft an attack? I could do the same thing going after other ones. I could see here is a Citrix NetScaler. So it's a pretty cool way to for us as attackers to figure out what is this web application firewall. Now, what I want to show you something is a little generic, but I want to get you into the mind of the attacker. And so that, again, you stop rationalizing, hopefully, if you are as a defender. So let's say we're going after this hospital, Pineland University Hospital.org, and the patient ID is 4321, right? Real simple. I'm trying to keep this simple. And it doesn't really matter what portal this is or if it's this company versus that company. I don't really care. I just want to get a point across. So when I do that, I'm going to probably get some kind of a response in terms of if this is a valid query, and I'm going to get some kind of patient ID back, assuming I have the right login. But even if I don't, let's just say it's some kind of query string that is being passed to the back end. Maybe I'm logging in with the wrong ID. It doesn't really matter. But what I'm going to do as the attacker is I'm going to change this to this here, script, alert, hi there, script. Now, what I'm assuming is that there's JavaScript here, and there's a variety of ways for us to figure that out. Now, what's going to happen here is if there is JavaScript, it's going to put a little box up on the screen that says, hi there. It's just going to pop up because the JavaScript's being interpreted. Now, what I'm really trying to figure out is what does your web application firewall do? And if I do this, 99% of all web application firewalls are going to block that request. And that's a good thing. Now, what I need to figure out as the attacker, and this is where the rationalization comes in, because people are going to go, oh, wait, I got a WAF, that would be blocked. So what do I do? Well, I try to figure out where the block stops. And the way we do that is I start taking off pieces of this code, this little trinket here, right? And if I still see activity blocked, I know, well, okay, the WAF is still doing its job. That's really cool. This WAF is pretty smart little WAF. The next thing I do is I take out more information, and the WAF continues to block. Now I go, okay, let me get rid of that, and the WAF blocks again. Now I take away this little bracket, and when I do that, I get this message. Now what that tells me as an attacker, a few things. One is your website's not configured correctly, just so all of you know, because I should never get back any kind of error message as an external user, ever. We see this a lot with a lot of applications. But I now know that there's a JavaScript error. And I should never get, obviously, back something that says activity blocked by a WAF. All of this should be one message, like, you know, inappropriate request, never ever telling me there's a WAF, and you should never ever tell me the type of error I got, missing closing bracket, line 607. But here's what happens. I now know that the WAF did not pick this up. So I got past the WAF. I'm past the web application firewall. And this is really important because this little silly technique is the exact technique we use to get past any rule. So if there's a firewall, if there's an AI system, if there's a machine learning system, I don't care what it is, pattern recognition, behavioral analysis, I'm going to use a very similar technique as an attacker to get past the firewall or get past whatever it is you have in place so that ultimately I get a different type of behavior. I'm communicating with your system. Your system's telling me, nope, 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 nope. Oh, sorry, I don't know what that is. Let me pass that on to the compiler, to the JavaScript interpreter, actually. So now what do I do? Well, now I try this. If I can get this is 62, CRH62 is an ASCII character for a right bracket. So this is still this. And when I do that, let's say I get missing end tag. Well, now I know I'm still past the web application firewall. The web application firewall doesn't know how to deal with this, so it forwards it to the JavaScript interpreter. The JavaScript interpreter is telling me, hey, this is inappropriate JavaScript. So I can go continue filling this line out until I get the JavaScript interpreter to actually accept my request and still get past the firewall. Does that take a little bit of time? Yeah, it does. Do I have a lot of time? Sure do. I don't have any deliverables by end of month or quarter. I'm an attacker. I can kind of make my own schedule. And we're a nation state, so we have actually 24/7 teams that can keep at this day and night. So I want you to just, this isn't about how sophisticated your WAF is or whatever. This is about understanding how attackers structure their attacks and how they kind of progress through a series of events to probe and test and get a response back. And again, it doesn't matter what kind of system you're using, the pattern is pretty much the same. Now, some of you are going to say, well, my WAF would pick up this thing. You know, they would see that 62 is an ASCII character or something like that. So what I can do is use math, right? I would just say CHR in parentheses X equals 30 plus 30 plus 2. So you're not going to be able to solve for every possible math equation that sets up to a 62 CHR. The reason I'm bringing that up again is don't rationalize. All defensive tools eventually fail because attackers continue to probe and try things. By the way, this here is not very sophisticated. This is a 2010 technique that still works today to get past firewalls, or whether they're web application firewalls or actual perimeter firewalls. I just wanted to use this because it's an easy way to illustrate getting around rules for firewalls. All right, so let's say we got our web application firewall. We figured out how to get past the firewall if we need to. We can update our supervisors around that and let them figure out what they want to do next. So next thing we have to do is locate and analyze the firewall. We want to analyze the perimeter firewall. So one way to do that is Nmap. And this is kind of a cool little thing that I don't know how many of you know about in Nmap. This -D here. This -D is what's known as a decoy trigger. Now what happens in this, when I go out and actually make an Nmap request, is the Nmap request is going to appear as if it's coming from this IP or that IP, right? And I can put as many IPs as I want here. Now, here's the thing I want you to keep in mind. We have a proxy chain, right? So we've already gone covert. People don't know our original IP. But what if, as the attacker, I figure out that who your ISP is, right? Who is your ISP? And I want to make it look like this request is coming from your ISP, but it's really not. It's coming from me in, I don't know, Romania or the United States, wherever my proxy chain shows. So when you see this in your firewall logs or in an alert, you're going to see the decoy address. And chances are you're going to go, well, that's valid traffic. I don't know why we're getting an alert on this thing. Or I don't understand why the ISP would do that, right? Or our ISP, that's our ISP's IP address, so we don't really need to care. Okay, this is a really clear example of not understanding either the attacker's perspective or the attacker's skills. This decoy gives me the ability that once I figure out your trading partners or valid IP, or maybe I figure out the IP range for one of your clinics or one of your office, your field offices, and I use that in my Nmap request. Very cool. I can also do RND, this random, right, in there. I can do a decoy random 3. So it's going to do a randomized set of IP addresses. And then I can target your environment, right? And what I'm going to see when I do that in Wireshark is that Nmap created these 3 IP addresses, 171.2.18. and 20. And you'll see that these 3 IP addresses are repeated over and over. And that's because it's continuing to carry out against the target a series of requests, but those requests appear to be coming from the decoys. And it's just going to continue doing that for however many numbers we tell it to run. And I can change that randomization number to be whatever I want. Now, the reason I do this is because a lot of behavioral systems will begin to break down if they see that, hey, these IP addresses appear to be communicating with us over and over. This must be normal behavior. So this randomization is kind of a cool thing because now I can start shaping behavioral analysis. So just something to know. Now let's say one of these actually goes through and I actually am able to get into the environment. I'm able to get to I bypass your perimeter firewall. I find that this IP, this random IP or this decoy IP that I gave you actually does get through. So this forms the basis for a very old attack called a fragmentation attack, right? This is what this -F means. And what happens when we do a fragmentation attack is we fragment the request, meaning instead of sending all the packets at once across the environment, we send only about 8 bytes. In Nmap, it defaults to 8. And we now, because we earlier, remember we said we got past the firewall. Somehow we were able to find an IP address that the firewall is okay with. So now what we want to do is we want to fragment the IP addresses. Now this was a very popular attack years and years and years ago. And some of the firewalls have gotten smart about it. And if they see IP fragmentation, as you can see here, fragmented IP protocol in Wireshark, they will block that automatically. So it's like, oh man, as a defender, you guys got me. I'm in trouble. Like you thwarted my fragmentation attack. And if you go look at a lot of documentation for firewalls, it'll tell you avoid, detects fragmentation attacks, right? And all of you are like, oh, my firewall, that could never happen here. I don't understand how you could detect a fragmentation attack with your IDS or IPS. I have a firewall that stops that. Well, here's how you get over it. You go back to Nmap, and there's this little trigger here called MTU, and you change that value. And what that does, you can see it here at 16, changes it in the transmission to 16 bytes. Remember, the default is 8. So I can change my MTUs to be some other value, which allows me to kind of thwart the firewall. Because now the firewall needs to either block all fragmented IP or certain lengths of fragmented IPs. And my hope is that it does one, maybe not the other. But the point of this is not to have 100% confidence in the tool, because there are ways to get around a lot of the things that people think are kind of these holy grails of defense, right? Now, for those of you that don't know what a fragmentation attack is, it's a pretty, like I said, it's an older attack, still works. We use it a lot to get through firewalls, even very new firewalls. But But it's basically just sending a bunch of fragments that eventually get to the target IP. That target IP doesn't know what to do with those fragments. So it crashes, right? It crashes the network layer and in the server or on the OS. And so if you're seeing servers just suddenly crash and you don't know why, maybe it's a fragmentation attack. Maybe somebody's gotten past your firewall, right? If you're seeing things reboot and they weren't supposed to reboot, and you thought it was, oh, maybe it ran out of memory, or maybe something else happened, or a bunch of services crash, right? You have a bunch of services running, Windows services, Linux daemons, whatever. Maybe it's a fragmentation attack. Maybe you need to look at that. Go look at the logs. Are you seeing evidence of fragmentation? My point on this is, don't discount it, right? This is the stuff that's being done. Okay, here's another one. This is a pretty simple Nmap attack, Nmap scan. And you can see here, oh, this port's filtered, right? But there's a problem with this port. And that port is that the way this port rule is constructed on the firewall, it shows up filtered. And if you go run an Nmap scan against this, you're gonna see filtered. And you're gonna be like, hey, my rule's right, it's filtered. That's what I want. Because none of us want an open port. But you can set up firewall rules that end up negating each other, especially if you have an advanced firewall, because they're harder to get the rules right, right? And this is why we always recommend getting a review of your rules done by the vendor of the firewall. Don't get a consultant to come in, get the vendor of the firewall to come in and look at your rules and make sure that you don't have some kind of situation that creates a porous firewall. So if I run a little bit different Nmap scan, what you see here, that filtered becomes open filtered, because this Nmap scan is a little bit more intensive, and it doesn't just take the immediate response and go, oh, it's filtered. What this one does is it actually tells me as the attacker, like, oh, it's filtered, but it's also kind of open. So I'm gonna go spend some time now playing around with this port as the attacker, right? So we're continuing to analyze what we can see on these ports and try to breach that firewall. Now, if that's not enough, there's a tool out there that some of you may know or may not know called Firewalker. This is a pretty cool tool. It was built way long ago, but it still works today, and it uses TTL to kind of go out and determine how to get past the firewall. What are the responses of the firewall? How does it gain a response from an internal address or not? If it does gain an address, it then attempts to get to that internal address. It does a bunch of stuff behind the scenes that we're not going to get into. I just wanted to give you an idea of how it works, and it works off of these time to live parameters and probes. But basically, the idea here is, okay, we want it to, for Firewalker to work, we have to have an internal IP address. And to get that internal IP address, you would be thinking, well, how are you going to get an internal IP address? And a lot of times, some of you are like, well, how does something ping my internal IP from an external IP? You can't do that. The firewall doesn't allow that, or I don't know, whatever you're thinking. Well, there's some things that go back to configuration, and it's not firewall configuration, it's the server configuration. So if you look at this here, all we did here was we kind of did a request, and it returned back to us a private IP. I'm not showing the private IP, but it basically allows us, and this is not the private IP, but doing that banner request returned back the internal IP address from an Exchange server. Now, how does that happen? It's a misconfiguration on Exchange and OWA. Now, I'm using Exchange and OWA as the example, but what you need to understand is just about anything that is in your DMZ, or even outside of behind the DMZ that is communicating with the outside world, if you don't have that 100% logged down and somebody grabs the banner or finds another way to make a request to that system, it can very well return the internal private IP address. And as you guys all know, that's not a good thing, especially when we come back to trying to get through firewalls. And what you see here is basically Firewalker in action with some dummy stuff, where it's going out and attempting to get to that internal IP address. And it will continue to ping and craft different types of packets until it tries to see that one of them actually will go through. And you got to just be really patient with Firewalker, because it can take some time, but you ultimately are trying to find different ways. So you go grab dinner, go out and watch a movie, whatever it is you got to do, and come back and see what your results are. And you can see that there are packets of interest here, right? And those packets of interest are going to be what you look at to figure out how to craft your attack. And when we talked about handcrafting earlier, this is the kind of stuff that we're looking for, to be able to get to that internal IP and appear as if we're normal traffic. Now, your IDS or IPS may pick up this kind of stuff because it's looking for these types of probes. Your firewall may not see anything in the firewall logs because suddenly you don't really look for that type of stuff because this is normal traffic. And we've also got our proxy chains, we've done decoys, we've done all kinds of other stuff to kind of shadow our activities or sit within your normal traffic patterns. DNS tunneling, I'm not going to go too deep into this, but the big thing here is, DNS is a great way to get attacks in through the firewall. Most firewalls allow DNS, especially external DNS servers, to communicate. And we can do all kinds of stuff on DNS to encode our own commands within that DNS and then pivot from DNS to other parts of the environment. So here's a big one. If you're seeing alerts in your environment and they don't appear in the firewall log, you really need to scratch your head and wonder, okay, has somebody used DNS to get into my environment and they pivoted? So you really need to think about like what's going on at that layer, because your chances are, you may have DNS open, or even if it's filtered, and the attacker can come in that way. And it's a pretty popular way to do it. Now, some of you are going to say, well, we subscribe to XYZ service and they look for malicious, blah, blah, blah. Okay, again, we're a nation state. We're cyber criminals. We're not stupid. There's at least 2 attackers that I know of are in the chat window, are in the chat. If I got with them and said, hey, let's go after XYZ organization and let's use DNS, we all know there are subscription services that block us. So what are we going to do? We're going to create a brand new domain that doesn't appear on anybody's watch list. And we're going to keep that domain very pristine. We're not going to allow it to be associated with any kind of nefarious activity so that nobody blocks us, right? We're not going to get a bad reputation. If we do, we're going to contest that reputation and say, hey, we're just really nice people that are running a bake shop. And I don't know why we ended up on this thing, right? So please, again, don't rationalize like, oh, we got a subscription service. Yeah, you got a subscription service that blocks a lot of script kiddies or block sites that have already gotten to what they need to do, and now they show up on the subscription service as a block or as a nefarious site. 0 days or new attacks don't use URLs or IP addresses that have already been declared as IOCs, right? You guys get IOCs, we get IOCs, attackers get IOCs. We can all subscribe to the same threat feeds, right? So unless you think the attackers are really stupid and they're like, oh, let's keep using this because the defenders are never going to figure this out. No, they're going to rotate, right, to another set of IOPs. All right, how hard is it to get a domain? Go to GoDaddy and you got one, right? How hard is it to throw together a fake website? Go to wix.com and you got one. So just keep thinking about the fact that stuff like this, if you're seeing behavior in your network, you really need to keep in mind that it's not that hard to go set up things that get beyond subscriptions and other kinds of behavioral analysis and things like that. I want to talk about SSRF a little bit, just real quick. This is a really cool attack. We've used this quite a few times, and if we were doing this nation state stuff against this UPA, we'd probably kind of sort of think about doing this. Here's the thing. What happens here is you have, and this is really hard for you guys to protect against, because what you're relying on is the security of your applications that are on the web. And the more you move to cloud-based apps, the more you're hoping that these things are going to work the way they're supposed to work. So if you have a website, and this could be anything, it could be your time management system, it could be a patient portal, it could be a payroll system, it could be a financial application, things that people are logging into. It can also be websites that are internal to your environment. Okay, so don't just think about these SSRF stuff being external. The way this works though is a user gets to, an end user or attacker rather, sorry, gets to this website and begins to do some of the kind of things I showed you with the WAF, but they're now they're beyond the WAF. They're on the application itself. And they figure out that this application actually connects to back-end systems. Maybe those are databases, maybe they're domain controllers if you're doing SSO, maybe their email systems, maybe their financial systems, whatever it is, they get to that system. And the way they do it is through crafting requests, right? So here's an internal IP, the 192 that you're seeing, and they realize, hey, I can actually query that 192 address. And once I get to that, I can start figuring out, can I start doing other things like, and this is a really simplistic, silly example. I didn't want to write a whole encoded string. So here you can see, I'm trying to get to admin, right? But the way this actually works is I pass in either an encoded string or a series of bash commands, or maybe PowerShell, or Windows commands, and I try to see what happens. Am I able to get anything back? And we can do some things called timing attacks, where I can figure out, can I get back some time indicators, and that can tell me logically, am I able to execute this or not? And I can go deeper into it if anybody wishes to talk about that stuff. But timing indicators or timing attacks are a really good way to do this, right? It's very low effort. Very low. It's very covert. Is what I guess I'm trying to say. Because all I'm trying to figure out is, does my action give me back a positive time indication? And if it does, then I know that I found a venue or a channel into the environment. The dangerous part about this is I am going to run under whatever the security principle is of this backend system. And I can tell you that a lot of applications, we work with a lot of organizations where we teach them how to write secure code. And one of the number one things we find are software engineers who encode admin privileges internal to their application. So yes, you log in as a user and you don't have admin rights, but when you make a request of the backend system, that backend request is being done as admin. And now I run as the system admin. So now if I can get this application to take this information from me, I've done a few things. I'm past your firewall. I don't need to go after your perimeter firewall. I'm inside your environment, and I'm able to pivot and run escalated privileges. I really wanted to put this in here because this is not directly going after the firewall, but for all of you out there that keep going, I don't see it in the firewall logs. All that's telling you is somebody got to this IP address somehow else. Not like, oh, well, if it's not in the firewall, there's absolutely no other way on the planet to get into your environment. If that's what you're basically saying, is I am so locked down that unless it comes through my firewall or my VPN, there is no way into this network. And what you need to understand is, I don't care what it is, if you have applications running on your environment and you did not write them, and you're 100% sure that those software engineers that did write them for that third-party company that happens to be in Yugoslavia is actually written them according to OWASP standards, hopefully you know what OWASP is, or to a very high level of writing secure code, then this exact attack is pretty easy to pull off. Okay. Sorry, don't know why my screen sharing is stopped. Hold on one second, I'm trying to fix the screen sharing thing. Okay, so hopefully you guys can see my screen. All right, so this is the last one I'm going to go through. The other thing about firewalls, because a lot of times I think people, and a lot of what we did in this presentation and as our task in terms of getting into this environment and trying to get to this other country has been about how do we get past the firewall. But one of the things we would look at if we were doing this in a real situation is, can we get to something inside the network? Can I get to an end user and deploy a rootkit? And this graphic right here actually is depicting an attack that was done against a cloud environment where a rootkit was devoid. Now, the reason I'm using this one is because this rootkit allowed external HTTP requests to pass through a firewall. That's what these little knights are. These are the firewall rules. And so the traffic inbound was based on a request being made to the rootkit. The rootkit was able then to take this crafted information and allow it to be deployed into the environment. So basically you got a rootkit in the environment. You were able to get past the firewall because of this customized little rootkit dude. And once you did, you actually were able to deploy additional malware, which allowed the attackers to establish command and control and then exfiltrate data, which is what this little dude who's a wolf is supposed to be doing. I don't want to go deep into this attack given the time and how much time we've spent on all this later, but I want you to start remembering that in some cases, the question isn't, can I get through the firewall and past it from the outside in, but can I get something in the environment that then helps me establish a tunnel to get traffic in and get past the firewall. So hopefully that makes sense. If not, I'm happy to discuss it further. This is another big one we see and that you can use, and that's telnetting to a switch. This is a real easy one where a lot of you may have or don't even know you have telnet enabled on your internal switches, and you have it enabled and you know about it, and it's externally accessible. We do this a lot with pen testing, and people always come back and like, oh my gosh, how'd you do that? I'm like, well, you've got telnet. We can telnet to your switches. And by the way, your switches are actively broadcasting. If I go back to the Shodan example, I can find your switches through Shodan. So just something to know. So based at this point, we've done a lot, right? If we take all the different techniques we've used, and from all the way from the very beginning, establishing our proxy chains, being covert, it's a pretty good day's work for attackers, right? We were able to demonstrate that there are multiple means of accessing the internal network through the firewall. We can get past the WAF. We have the ability to use SSRF. We have the ability to deploy a rootkit if we need to get a command and control. So a bunch of ways that we can get into this environment that are pretty powerful. I'm going to pass this. We'll talk about it on the next one. But my hope, again, was to kind of give you guys something to think about in terms of how you're structuring your defenses, but more importantly, to kind of take the position that not any one defense or multiple defenses, should allow you to establish a false sense of security. You got to think about, hey, if I'm seeing an alert, am I just thinking this alert, like this tool just likes to generate alerts for whatever reason? Or is there something going on here? Somebody DNS tunneling? Is somebody getting SSRF? Is somebody doing decoys? Has somebody figured out my traffic patterns? Do I have rules that work against each other? And now, somebody figured out that something that's filtered is actually open because the rules are negated. What is going on? So a lot to take away. We went a lot longer than I ever expected, so I apologize for that. I'll try and get these shorter in the future, unless you guys tell us like, no, hey, don't shorten them. But if you have questions, I'm happy to take them. Some of you are going to tell me you have really 4th, 5th generation firewalls and none of this would happen. Okay, that's fine. I don't know how that prevents SSRF or some of the other techniques, but if that's what you would like to believe, that's cool. So I guess, Laura, with that, any questions?
We don't have any questions at this time.
All right, so if you guys do have suggestions, feedback, thoughts, something we can help with, my email's on the screen. Hopefully you guys will be part of the next session, and I really mean it. If you guys want to do a session, if you have something you're passionate about and we can help provide that platform, then reach out to us and we'll do that. We really are trying hard to build a community of people that can help each other and be there for each other when things do go south, not just when things are good. So with that, hope you guys have a great rest of your week. Hope this was valuable and look forward to talking to you on the next event. Thanks. Bye.